Well, hello, fifth graders. We're going to go over your literature anthology story. It would be in your key whole book, the large book, and we are still on Unit 5, Week 4. Our story this week is When is a Planet Not a Planet? And it is expository text. We know that expository text is nonfiction, but it goes a little bit farther. There's a few more characteristics or attributes of expository text that we should be familiar with. One of that is it will present information and facts about a topic in a logical order. It will support specific points with reasons and evidence. And then we will have text features. We'll see those captions, we'll see those photographs, illustrations, diagrams. We'll have headings and we'll have subheadings. So while we're reading, we will be looking for some of those so we can just cement the idea that we can identify expository text, which would be one of our learning goals for the day. The other one is, or the other thing we want to be thinking about is the essential question. How can scientific knowledge change over time? Which leads us to another learning goal for the day, which is we should be able to use that comprehension strategy to help us stay focused and engaged when we read a text. And that comprehension strategy for the week, or this last 2 weeks, I should say, is asking and answering questions. So right away, this essential question leads me to already start naturally using this strategy. Right now, I'm asking myself, why? When is a planet not a planet? It starts with that question. We know that technology changed over time. I'm asking myself, what technology changed over time? What sort of advances in technology helped us find out new things about space? I also want to know what things changed about space. So these are some questions that I'm asking myself as I read to help me stay focused and engaged. There are two things that I'm going to ask you to do while I'm reading this story. One is sometimes I'm just going to stop. I'm going to ask a question and then I'm going to ask you to pause the video and then formulate your answer or think about your answer to the question I asked. Then you'll just unpause and you'll check your thinking with mine. Sometimes I will ask a question, but I'll show you that it will be one of the questions that is on the Google slideshow that has been assigned to each of you. So each of you have your individual copy of the slideshow. There will be questions that you will answer along the way. And at that time, when you unpause, I won't be revealing the answer to check your thinking. These will be questions we'll go over when we meet in our Zoom session. So sometimes I'll point out when you can go back to this PowerPoint or slideshow and fill in those answers. And sometimes I'll just be asking you questions and wanting you to pause and think about it and then come back to me to check your thinking. Okay, so let's get started. Let's start on page 405. And you can follow along at the very top. It says a silly sentence, yet school children have memorized it for years because it helps them remember the planets in our solar system. The first letter of every word stands for a planet in the order of how close it is to the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Mercury is the planet closest to the sun, and tiny Pluto is the farthest away. That is, until recently. Pluto is still there, of course, along with the planets, asteroids, comets, meteors, and bits of space rock and ice. Pluto is part of our solar system. Pluto and all those other objects orbit or travel around the sun. Orbit is one of our vocabulary words, so we know it is circling over and over. And so we know all of those objects are circling our sun more than one time. We also have a text feature. On this page, we have this caption. So let's go ahead and read that caption. And it says, this is a composite of photos taken on many different NASA missions. So a composite is lots of photos put together to make one. So then the artist can show us more clearly and easily what they want us to know. So this particular composite illustrates our solar system. Our star, the sun, is at the far left. Pluto is at the far right. The wispy tail of a comet is shown in the lower left, and the Southern Ring Nebula is near the lower right. The other faint objects in the image are artistic additions added by the computer. The other thing on this page that I need to point out is we do have a Greek word in here, some Greek roots. We have one word in particular that has a Greek prefix and has a Greek suffix. So the word asteroid has a Greek prefix, aster, which means star, and it has a Greek suffix, oid, which means like. So the word asteroid would mean star-like. So there's a few other words we're going to encounter that also have at least that Greek prefix, aster. So I'll be asking you to look for those when we come across them. All right, let's go ahead and we are going to go to page 406. And you can follow along starting at the top. And it says, however, on August 24th, 2006, the International Astronomical Union, the IAU, a group of individual astronomers and astronomical societies from around the world made an announcement. So right there, I have that Greek prefix again. So I know that their jobs have to do with stars or space. So they declared that Pluto was not a planet. Suddenly, my very eager mother just served us 9 pizzas didn't work anymore because now there are only 8 major planets orbiting the sun. Perhaps someone will create a new sentence to help us remember their names and order. Names are important, but they are not the only things to know about the planets. Learning how planets form, where they are located, and what they are like is the kind of activity that makes science exciting and fun. All right, so right here would be your first opportunity, if you choose to pause the video and then go to your slide. Your slide 2 has question 1, and it says, why doesn't the old memory clue for planets, my very eager mother just served us 9 pizzas, work anymore? So you'll click down in here, you'll type your answer, and then when we get together in Zoom, we'll go over that. So you can pause if you want to. Otherwise, I'm just going to keep going. All right, so we're going to start on 407. It's called Pluto's Problems. It says there are 2 groups of planets in our solar system. The planets closest to the sun, Mercury, Venus, Earth, and Mars, have a solid surface made of a mix of rocks, dirt, and minerals. The planets farthest away from the sun, Jupiter, Saturn, Uranus, and Neptune, don't have a solid surface. They are made up mostly of gas with a rocky core. Scientists have a theory about why some planets are terrestrial or made of rocks and dirt, and I like that context clue for terrestrial. I'm knowing right away, because it's that definition context clue, it's made of rocks and dirt, and why some are composed primarily of gas. Most scientists believe that our solar system began as a space cloud called a nebula. The nebula was made up of bits of space dust, rocks, ice, and gas. A tiny star not yet ready to give light began to form in the center of the nebula. The star was our sun. As years passed, the sun grew big enough that high temperatures and extreme pressure caused hydrogen at the center of the sun to begin to fuse into helium and release energy as light, sunshine. Meanwhile, the nebula continued to orbit the new sun until it formed a large, flat ring around it. Scientists call this ring a protoplanetary disk. The disk or ring was hottest where it was closest to the sun and coolest at its outer edge. As the disk swirled around the sun's gravity went to work. It pulled and tugged at the bits of rock, dust and ice and gas until they came together in clumps of material we now call the planets. We do have one context clue here. It is a little caption. It's going to tell us what's going on here. So we'll read that. And it says, an artist's conception of a protoplanetary disk forming around a sun. So we know this isn't a photo. An artist made this sketch, but we can see this would be the star they're talking about, and this would be the disk that is forming around the star. All right. While I was reading this page, I also was engaging with that comprehension strategy of ask and answer questions. As I was reading Pluto's Problems, the word nebula came up, and it made me think, do I really know what that meant? So I had to ask myself, how could I find out? So the first thing I do when I ask myself that question and I want an answer is I might need to reread. So when I reread right away in that first sentence in that second paragraph, it tells me that a nebula is a space cloud. Then I get a visual from there. All right, so now I have two questions for you that are not on the slideshow. The first one I'm going to ask is, I want you to reread page 407. What does this section describe? So you're going to pause the video for a minute and then just click back on when you want to check your thinking with mine. My thinking was, it describes how scientists think the solar system formed. My second question for you for this section is, how does the author use this section to support her ideas about Pluto? So again, pause and then hit play again when you're ready to check your thinking. All right, I felt like Pluto didn't fit the theory of the solar system's development, which is what this section describes. Unlike the planets most distant from the sun, which are Jupiter, Saturn, Uranus, and Neptune, Pluto is not made up of gas. It is solid, similar to the planets closest to the sun. So right away, I feel like the author is including this section, Pluto's problems. It's showing us how Pluto's different. Pluto doesn't fit what's going on with the other planets. All right, you also have one more thing you can do, which is on your PowerPoint. Here, your slide 3, which is question 2, says, what happened when the sun grew bigger? What effect did the sun's gravity have? So these are a couple cause and effect relationships. The first one is the sun grew bigger. That's a cause. So we want to know what happened because the sun grew bigger. What happened because of it is the effect. So you'll come in here, you'll click and you'll type the effect. The second cause they give us is the new sun had gravity. So because the new sun had gravity, what happened? Go ahead and type that in there. This is where I won't be giving those answers right away. We'll be talking about them in Zoom. All right, let's go ahead and we're going to go to page 408. And let's start at the top, which is the planets. So you can follow along. The planets that were closest to the sun didn't keep much of their gas. The sun's heat blasted it away, leaving behind solid spheres of matter with only a little gas. Those spheres became the terrestrial planets, Mercury, Venus, Earth, and Mars. But on the outer edges of the disk, far away from the sun's heat, it was much cooler. The clumps of rock and dirt there still had their thick layers of gas. They didn't burn away. The planets farthest from the sun became the gas giants, Jupiter, Saturn, Uranus, and Neptune. We also do have a caption here, so let's go ahead and read that. That would be a text feature, so with this photograph. And it says a small portion of the Orion Nebula, and again, I know that's a space cloud, 1,500 light years away from the Earth. At least 153 stars in this region have protoplanetary disks swirling around them, forming new solar systems. Scientists believe our solar system formed in just this way. So the caption tells us that the photograph shows the Orion Nebula and explains, so right now it's giving us more information than the text did. It's telling us what this is. It's also telling us that 150 stars with protoplanetary disks are forming new solar systems. And the caption relates the information to a nebula, which we talked about on the previous page. Okay. I'm going to stop it here, and then you'll have to click on part 2 of this, and then we'll keep going.